So, we are zooming in, as you can see. Now we start with the actual topics. And we start friendly. As I told you, you were taught about descriptive statistics, or sometimes maybe called explorative data analysis, explorative statistics, already in elementary school. And then again in high school, I know. And now we do it again. And we do it for a reason. Because even though this course is really not about descriptive statistics, you could say, the main purpose of this course is take you the next step to the further, one level further, to be more intelligent at a higher level in how we can learn from data. But we should not forget the basics of looking at data, visualizing the raw data. Whenever you meet a new data set, if you become a data scientist or a statistician or a machine learner, you name it the way you want to name it, then the first step whenever a data set hits you is to start looking at the data by simple means, simple statistics, summary statistics, simple plottings, 1D plotting, two-dimensional plottings, all sorts of simple looking into the data structure to get a feeling of what it's all about, what's there. I can already now see some odd thing going on, just to learn about what the data really is, and as an idea generator to what kind of modeling could even make sense to do. Of course, you might have some research questions or some specific business questions given to you by the teacher or by the client, whatever situation you're in, but still, don't count on the client knowing all the questions. That's the thing I've learned. They come and ask you about a number of questions, and half of the questions don't make sense, and then all the best questions they didn't ask. I mean, if you don't only want to answer their questions, then fine, then you're not a brilliant data scientist or statistician. Then you're just okay. Maybe you make them happy. If you want to make them more than happy, you have to think about questions yourself and question generating processes by looking at data, understanding the situation. We begin, we have a set of 4 points to go through here. You will be forced to do that as a part of the mandatory projects, which is data analysis projects. Here it comes, the first formula in the course, and I hope a well-known one. How do we compute the sample mean, or sometimes just called the mean? Well, we add up the numbers and we divide by the number of data points. Here we go. If you're not so much into math, you might already be a little confused. I know many of you are not confused. A few could be confused. We have a diverse audience in this course. Some of you could be confused about this mathematical notation, the capital sigma, which is the Greek capital S for summation. Well, it's nothing complicated at all. I'll show you in a second. It just means add up all the numbers. S for summation, right? So it's mathematical symbolics, but it's a simple concept. The other measure of centrality, of the middle place of data. Envision, when I speak about this, envision that I have a data column of maybe 100 or 1,000 or 1 million data values in front of me, and I'm going to tell the story about these data by some few summary statistics. The first one I would find out would be the mean. The next one could be the median. The median is similarly trying to tell a story about the middle of the data, of the distribution, if you want, but in a different way. The median is the middle point. There are different ways to say the same thing. Order the data. If I have the numbers 1, 2, and 3, what's the median? It's the number 2 because 2 is in the middle. 2 has 1 to the left and 1 number to the right. So you just count how many is to the left and to the right. In this case, 2 is also the mean, right? The mean of 1, 2, and 3 is 2. The median of 1, 2, and 3 is also 2, by chance. Example, of course. I do a little random sample. Now I won't do it. The time is not up for it. Among you guys in here, and if you can read it, you will see I sampled 5 persons Actually, you have your first R code thing. This is how you could put those 5 numbers into R. A ridiculously small sample, of course, but just to have something we can follow now. The mean, you add up the 5 heights and you divide by 5. We have a mean height here of 185 centimeters. How would I find the median? I would first order the data. Here's the same 5 numbers in an ordered sequence from smallest to largest. Then I choose the middle. When choosing the middle, we have 2 situations that could occur to us. First of all, if the n is uneven, the middle number is well defined to be 184 centimeters, which would be the 3rd number. Now we make a thought experiment. I am envisioning a new situation where I'm adding 200. We had an American basket guy coming into the sample. Let's just, for the fun of it, think about how would the mean and the median now be for the new data set. That gives us a bit of insight. And here is a new thing, actually. I believe I found a typo. Typos do occur. If you ever see a typo and you see me jumping around in the typo as an idiot, well, I guess that's entertaining, but it's not fruitful. So please stop me and correct the potential typo in the benefit of everyone, right? So don't hesitate to suggest typos. It's okay to come with typos even though none are there. Let's see. What is the mean? Well, I would add up the 235 and divide by 6. I don't show you the formulas, but anyway, look at how the mean actually changes quite drastically due to this single kind of extreme observation. What about the median? I should add 235. Then I should take the middle number. Well, the middle number is not there because it's even, right? I have 3 to one side, 3 to the other side. Then the rule I'm going to show you on the next slide is that the median, and that's the typo, would be the average of the 2 middle numbers, like that. But still, the median hardly changed, right? I added in an extreme basket guy, and the median is the same, basically, right? So the median is a more robust way to tell a story about data. It's not like one is correct and one is wrong. It's just 2 different numbers that makes a difference whenever the data is not nicely symmetrical. In symmetric situations, they are more or less the same thing. If it's not symmetric, the median might be chosen to tell the story for many reasons. Let's see. Yes. We have just a little game, and then we have the break. I do 2 by 45 minutes with a 15 minutes break. That's how I'm aiming for going through with this. Let's do one question more. You're doing good. Thank you. You have deserved a 15 minutes break. There you go.